All right, let's get started. Welcome back, everybody. I feel like it's been a few days since we've done one of these. Today's topic is sorting algorithms. That's going to consume us for the next few lessons. We're going to look at a few different ways of sorting things. One of the reasons that we typically explore sorting in this course is because it's, first of all, a really important building block for a lot of other algorithms. So we'll look a little bit on Friday, I think, at one particular task that becomes very easy once data is sorted, which is searching. And so, sorting may seem like sort of a basic thing to do. It may seem like something that's not that complicated, but it turns out that sorting is sort of a baseline algorithm for a lot of other algorithms that operate on top of it. And so there are still ongoing, and I'll include some information about this in one of the upcoming lessons, there are ongoing competitions actually that are still being held year after year after year for creating efficient ways of and fast ways of sorting large amounts of data. And by large, I'm talking about like large, like petabytes, or if you're Google, for example, Facebook, companies that have access to massive data sets. Sorting, you might have so much data it doesn't even fit into one machine. So now you've got to write sorting algorithms that can operate across a whole cluster of machines, and so things get pretty interesting. From our perspective, we're not going to be sorting that much data, but we are going to look at sorting as a problem, partly because it gives us a chance to do some algorithm analysis, and also because we get to see kind of a mixture of some neat algorithms. There's a gazillion algorithms in this space too. I mean, that's the other thing that's fun about sorting. If you go to the sorting Wikipedia page, you can find, I don't know, a list of like 100 different sorting algorithms. People are still coming up with new ones. Some of them are silly. Some of them are real attempts to solve the problem that have different performance characteristics and different trade-offs. One of the things I like to point out to people about sorting as a problem is that the sorting algorithm used by default by Java, I think it originated in Python, but now it has spread to Java and a few other languages, is a sorting algorithm that was only developed 18 years ago. Now, you might think, well, I mean, at least it was in the aughts, right? Like it was 2002. But sorting is such an ancient problem. I mean, sorting goes back, before the days of even computers, right? You can imagine people had large amounts of like paper records that they needed to organize or whatever. I actually had this is bringing back bad memories of a summer internship I had where I had to, I at one point was anyway, it's a long story, but I was locked in a windowless room in some, I don't even know what the company did, to be honest. I think maybe they were a law firm. This was only a few weeks at the end of the summer before I went back to college. I was doing these terrible temp jobs, and they threw me in this room to they had their filing system up to that point had been just like dumping files into this room. It was like somebody would like open the door to this room, tip a basket of files into the room, and then slam the door before everything started to fall out. So my job was to organize this. And it's interesting. I mean, looking back, that was before, I think I'd taken a few computer science courses, but I certainly wasn't thinking like a computer scientist yet. But now, if you asked me to approach that task, I would have done a few things quite differently. Anyway, so sorting is something that people have been trying to do for a long time, certainly since the dawn of the computer era. And so I think it's kind of cool, actually, that the default sorting algorithm in these major languages is only 20 years old, even if that seems like a lifetime ago to some of you. All right, so let's talk about some of the ground rules we're going to set for sorting, just for the purposes of our example. So we'll sort in ascending order. There's lots of different ways to sort. I should say, I mean, typically we're going to look at numeric sorts. There are other ways to sort things. We'll also sort arrays of integers. Just because it's simpler, although some of the homework problems that we'll do will have you sort not arrays of integers, but instead arrays of comparables, because you can. Because in Java, once I make something comparable, once I implement that interface, one of the things I can do now, which is one of the reasons why it's useful to implement comparable, is that I can sort stuff. All right, so, and we'll look at a couple of these. There's an example today going through bubble sort. We walk through insertion sort, which is what you'll implement on today's homework problem. We may, tomorrow will be sort of devoted to merge sort. We'll do quick sort on Thursday. I may sneak selection sort in at some point because it's another commonly used algorithm. and maybe at some point we'll do BOGO sort, which I'll let you look up on your own. That's a fun sorting algorithm with some particularly interesting performance characteristics, namely awful performance characteristics. All right, so the rest of this is really just sort of going through, first of all, we'll implement is sorted together, doing that. And then the next one is actually doing bubble sort, which is a particular sorting algorithm that sorts things by looking for mismatched items and swapping them. And if I do this enough times over and over and over again, you can think of bubble sort as making the array a little bit less unsorted every time it goes through. If I repeat this step enough, if I repeat this step enough times, I can sort the entire array. That's not a particularly good way of doing it. The next thing we do is we go through a video showing you how to approach insertion sort, or the particular type of insertion sort that we'd like you to implement for today's homework problem, and then you get to take a crack at it. So it's our first chance of doing a homework problem. Kind of a neat sort of reintroduction into imperative programming, which we hadn't done much of, and also an iterative algorithm, where we had been looking at more recursive solutions recently because we were working on trees. We'll get back to recursion tomorrow when we talk about merge sort and when we talk about quick sort, which are both recursive sorting algorithms. All right, questions. I've said probably all there is to say about today's material. I'm happy to take questions. If you guys want, we could pick a different sorting algorithm off the heap to look at or to analyze, or we could go through kind of some of the characteristics of some of these algorithms, look at some of the performance aspects. I will yield the rest of my time, and I'm happy to take questions about sorting or some of the tree material, or whatever you guys are curious about at this point. Get into some tea here. The cat today is upstairs so far, at least, but sometimes this is kind of the time of day, I think. I don't know if she hears me talking or if that's her cue to come downstairs, but we'll see if she joins. Yeah, great question. So when we compare, so actually that's kind of a fun segue. So why don't what we do is why don't we implement is sorted for comparables, right? So we did this for ints. And I think sometimes, making the transition to comparable, if you can come up with an algorithm that works for numbers, then you can change that fairly easily. So our is sorted algorithm for ints, and I'm just going to simplify this slightly, I'm going to assume that array is non-null, is I go through the array. Now I want to look at pairs of elements. I don't want to look at, so I'm going to go through array.length -1, because each step I'm looking at pairs of elements. And if array has n elements, it has n-1 adjacent pairs. And then I say if array I plus 1 is greater than array I, return false. So if I find a spot in the array where, backwards, yeah. If I find a spot in the array when the next value is smaller than the current value being array I, the next value being array I plus 1. I could also write this way. I could say if array I is greater than array I plus 1, so array I plus 1 is smaller, then I found a counterexample. I found a spot in the array where things aren't sorted. So this works fine. Let's make sure that it works make sure that it can identify places in the array that are unsorted. Okay, perfect. So now let's imagine that we do this based on comparables, right? So now what I'm going to do is I'm going to change this to accept an array of comparable objects, any object that implements the comparable interface, an array of those. And now what I need to do is just, I can't do a less than or greater than on these. Instead, I need to compare them, and then I need to do something with the result of this. Let's see here. It's too early in the morning for me to think through compare to. And now, now what I need to do is use an integer array, because that will work rather than int array. There you go. So now what I've done is I've transitioned my original is sorted algorithm, which only worked for int arrays, to one that works for comparables. fairly straightforward way. So the question is, how does this work with 1, 2, 5? What order is this? I have to, does that have to be strings? I could just do this like, we'll do this upcast at will, okay. And so the question is, what sorting order is being used for strings in Java? And one way we could do this is just mess around with this and see if we can get it to work. So let's try putting 5 at the beginning. And now that succeeds. So this array is sorted according to the compare to method that strings are implementing. So let's look at how this works in Java. So we'll look up string. I just really want the string Java doc. I don't need all of these bad explanations. Let's try to find the Java 14 string. I don't know why they changed all the URLs. It's really irritating. Here we go. Okay, so it implements comparable, and it can be compared. We'll talk a little bit more about later why that interface is parameterized. But now let's look up compare to. It says compares two strings lexicographically, which may just be another way of us being like, what does it do? So this is the definition of lexicographic ordering, and then it goes on to do that. So it's doing this according to the ASCII character table. And if we look at the ASCII character table, let's see, ASCII, this is, to be honest, a little bit of a strange way of doing it. I'm not sure if I am fully understanding this, but let's look at this. So in this table, the letters are in order, A through Z. The lowercase letters come after the uppercase. So let's make sure that works. Let's try putting a string that has a numeric in here to make sure that it goes at the beginning. It does, okay. And so if you look at where the numbers are here, they're lower than the capital letters. So that should imply the capital letters should also come first. So if I do 5, that should work, right? If I put capital 5 after this, it doesn't work. And I actually think it has to be, let's try like capital 2. Yeah, so it has to be all the way in the front. So capital 2, despite the fact that T comes after F in the alphabet, all the capitals come before all the lowercase letters in Java's default lexicographic ordering. And so on some level, every lexicographic, I'm not saying that properly, lexicographic ordering is inherently arbitrary, just like letters are inherently arbitrary. And so here it looks like what Java is doing is just relying on these ASCII character codes. Now, if we were going to go, let's see, let's get some emoji. Let's figure out where the emoji go in the table. Here we go. There's some emojis that we can cut and paste. So let's try this. This should work because I got this to work earlier this semester. Look at that. There's a weird space in there. Okay. Yeah, it looks like the emoji come at the end. Let's try to put them somewhere else. I love that this works. So it took a few minutes to get this to work, but yeah, okay. So the emoji are now out of place. So emoji go at the end after the other characters. And I'm sure we could figure out, let's look at Chinese characters. Let's find a couple of these. There's a name for these, right? Kanji, is that what they're called? Or is that Korean? Okay, I just want to cut and paste these. Sorry, Hanzi. Here we go. Let's get a couple. I should be able to type these in as well. Where do these go? Nope. I don't know why it's not letting me paste here. Copy. Let's try this. Okay. Yeah, so it looks like these characters, I suspect that they go before the emoji. And now it's angry about something else. Oh, there we go. Oh, here. There we go. Yeah. So again, there is some well-defined order for every string in Java, even strings that include special characters. I don't consider the Chinese characters to be special, but non characters that aren't in the original ASCII table. These have character codes that are just higher than the original ASCII character codes. So there is a well-defined way of ordering strings in Java, and that's what's used if you don't. It starts with the first letter and then you go from there, right? So for example, if I have I think the idea is if I have a string that's longer, it goes after the shorter string. Yep. I think that's just convention, right? If I put this here, it's the same characters, but it has another character. Yeah. So yeah, there's just it's just done by convention, right? And it's sort of arbitrary. I actually don't know. I mean, it's a good question. I'm not sure this is really what's considered dictionary order, at least for English. Let's look this up. Let's see here. Dictionary lexicographic order. Anyway, maybe this is also what's used by dictionaries. I wasn't aware of that. I don't think that's actually true. I think dictionaries tend to mix in. I think dictionaries tend to put capitalized terms mixed in with in the same area with the letter, right? Probably because sometimes the capitalization of a particular term is either something that changes or not known by the person looking it up. So if I was looking up like internet, for example, so internet was a word that, at least according to, I think, the Oxford English Dictionary, was actually capitalized for a period of time and is no longer capitalized. I think they've decided now that, or wait, maybe it's the other direction. Maybe internet was not capitalized and now it is capitalized. I can't remember, but they've decided to change the capitalization. Good question. Back to here. Other questions about sorting, or really anything. Let's look up. Let's see if we can find another sorting algorithm to implement. That's what we can do. Oh, there's some really cool visualizations of these, by the way. Really fun. Okay. Yeah, shell sort. Comb sort. Yeah, some of these get, I'm sure we can implement this, but some of these get interesting. Oh yeah, I think that's how it works. Yeah. Does the gap value go up? Yeah. Yeah, that's right. So that's kind of a neat. I mean, you can sort of think about it compared to bubble sorts, right? So the idea behind, I'm just vamping because we need 2 wraps to sort for 1, 2, 5. So insertion sort, the performance of insertion sort, which is I think what you're asking about, depends on the data that you put in. So on some level, insertion sort starts growing that sorted portion, and so there are times. So imagine you're doing insertion sort on a sorted array. For many sorting algorithms. So one of the features of real world data, and we'll come back and we'll mention this when we talk about quicksort in a few days. One of the things one of the characteristics of data that real world sorting algorithms encounter is that a lot of times they're run on data that is almost sorted. So you can imagine that your program is like maintaining some sorted data, right? Let's say you have a list somewhere and that list is sorted. And when you add values to it, you do so in a way that maintains or what you might do is when you add data to it, you might append it to the end and then sort it again so that you maintain it in a sorted fashion. Because of this, or here's another common use case. We'll talk about this tomorrow. I've got 2 sorted arrays and I concatenate them. So I create one larger array that has, or one larger list that has all the elements from the smaller list, and then I sort them again. And so in that case, I've got a big chunk of sorted information and a big chunk of sorted information, and I'm trying to merge them together. What we'll point out tomorrow when we talk about merge sort is that that merge is actually can be done quite efficiently if I know that that's the case. But a lot of times what happens when I run a sorting algorithm is I just give it a list. And it doesn't know, for example, that the list has 64 elements and the first 32 are sorted and the second 32 are sorted. Or it doesn't know that the list has 64 elements and the first 62 are sorted and the last 2 are out of order. And so one of the things that real-world sorting algorithms, particularly sophisticated ones, try to do is they try to make sure that they work very efficiently on data that is almost sorted. And so if you think about how insertion sort works, right? Insertion sort, in each step, if the data is already sorted, what is it going to do? It just goes on, right? Because it notices, so imagine insertion sort running on data that's already sorted. It's ON, because in every step, that inner loop terminates immediately because it's, oh, okay, it's all in the right spot, right? So it starts building that sorted portion, and every time it doesn't have to move, it doesn't have to do any swaps because the item's already in the right spot. So imagine I'm doing insertion sort with a very big array where most of the data is sorted, but there's a few items at the end that aren't sorted, or at the beginning. What insertion sort will do, particularly if they're at the end, is it'll just race through most of the array very quickly, and then at the end it picks up that one item and just kind of like drags it into the right spot, picks up that other item, drags it into the right spot. And so, for a very, very large array, if there's a very small of unsorted data in it, an insertion sort can be quite efficient. One of the things that this new sorting algorithm that I've been talking about, which is actually called TimSort, that came out in 2002, one of the ways that it works is that it tries to identify portions of the data that are already sorted. So it calls these runs, right? So essentially, one of the things it does is it looks for chunks of the data in the portion that needs to sort that are already sorted. Because if those are already sorted, it turns out that there are efficient ways to merge them with other parts of the same data. So it depends on on the data you need to sort. Now, for insertion sort, let's say that whenever you're doing this, you try to think of, okay, what's the worst case input. So for insertion sort, the best case is data that's already sorted. That's ON, right? Keep in mind, it's ON just to check if something's already sorted. So even just to figure out that the data is sorted is ON. So I can't do any better than ON with the sorting algorithm, right? I mean, if just checking the data to see if it's sorted is ON, then there's no way that I can both check the data to confirm it's sorted and fix any problems in anything better than ON, right? So ON is the absolute best case runtime for any sorting algorithm. If I know the data's sorted, then it's O1. It's just like you told me, right? But if I actually have to examine the data, ON is the best I can do. If there's a few unsorted items in the array, insertion sort can be very close to ON. However, if the data is like backwards, for example, then if you think about it, so imagine the data is sorted in reverse order. And you can kind of go through this, when using pen and paper, or just sort of, even print off the array. Once you finish insertion sort, move it to a playground, print off the array, and see what happens. In every step, the item that so think about it. If the array is sorted in reverse order, the new item that I'm adding to the sorted part is always the smallest item in the sorted part of the array, and so it always has to go all the way to the front. So in every step, I'm taking a value from the unsorted portion and I'm moving it all the way to the front of the sorted portion. I don't know that it goes in the front. I have to check. But essentially at that point, now I'm at ON squared, because every single time the outer loop runs, the inner loop has to move that value all the way to the front of the array. So the runtime of any sorting algorithm is always dependent on the data. I shouldn't say that. There's one algorithm, we'll talk about merge sort tomorrow. Merge sort is like extremely consistent. It does not have a data dependency. Many sorting algorithms do have a data dependency. So what that means is that if you give them a certain array, they can complete very quickly. If you give them another type of array with different features in it, they may take longer, right? Merge sort is an example of one that has no data dependency. The runtime is always the same. But many sorting algorithms, the runtime depends on the data you give them. So you can't make an argument about the runtime of a sorting algorithm based on a single input, right? You have to think about many, many different inputs and how it would perform in practice. So that's the, that's the way to think about it, right? If you might have one, so again, like the 1, 2, 5, right? So 5 is the only value that's out of order there. 1 and 2 are fine. So 5. So this is essentially a sorted array consisting of the values 1 and 2, and then one new unsorted value at the end. And that's really the best case scenario for insertion sort. It's a good question. Other questions? We're talking about sorting. These are good ones. Yeah. Data dependence, definitely. And we go through that a little bit here today, where we talk about, the fact that even bubble sort, right? If you give bubble sort sorted data, it'll just blow through. I mean, essentially what bubble sort is with sorted data is sorted, right? Because, you can think of, you compare, basically this says if these are out of order, then I return false. What bubble sort does is if it's out of order, I mark that I swapped something, and then that means I have to continue. I have to go through the array again because it's possible that it's still unsorted. If bubble sort goes through the array the first time, it doesn't find anything to swap, it finishes. And so it's essentially ON. So on the other hand, if bubble sort has to, again, move a value all the way to, so that's, so if you think about, bubble sort versus insertion sort, right? Insertion sort is considered to be, at least in certain cases, a viable sorting algorithm. Bubble sort is not. So let's think about why. So think about that case where I've got data all sorted except for one new value at the end that's not sorted. So how long is it going to take to sort that? Well, what is insertion sort going to do? Insertion sort is going to blow through that beginning of the array, seeing only sorted data. And then at the very end, that last value, it's going to have to move it into the array and find the right spot. So that single step takes n over 2, right? I mean, it's n over 2 swaps. It might be n because I might have to move it all the way to the front. It might be 1 because it might already be in the right spot or very close to it. But on average, it's n over 2. So the outer loop runs n times, and the inner loop runs once n over 2. So we're still roughly on. We have n for the outer loop plus n over 2 for the inner loop running once. And so we're still, it's kind of like O2n, right? And we ignore constant factors in this class, and so we just say, we ignore multiplicative constants as well as constant factors, right? And so that's just on. Bubble sort, okay? So again, same setup, and maybe we'll do this tomorrow in the lesson just for fun. Same setup, already sorted except for one new value at the end. Insertion sort, bubble sort. So insertion sort, on. Bubble sort, what's going to happen? Well, this is the worst case for bubble sort, by the way, because that value at the end has to go all the way to the beginning, right? Insertion sort, or somewhere in the array, insertion sort takes it there in one shot. It immediately grabs that value and drags it into the right spot. Bubble sort can only move it one step closer during every round of that inner loop. So what's going to happen? The first time the outer loop runs, I'm going to do one swap. And so that value is going to get one chunk closer. Next time through, one swap, one chunk closer, one chunk closer. And it has to do this over and over again, right? So now I'm talking O(n) squared for bubble sorting. And that's a case where a good sorting algorithm should be able to do better. And so, that sorting algorithm that I was just sort of picking up off the Wikipedia page a minute ago, this comb sort idea, so it's kind of cool, right? Bubble sort, I only ever consider the two adjacent values. What comb sort does is it allows me to choose values that are farther apart. So imagine that instead of just looking at adjacent values, I look at values that are separated by 4, and I swap them. And then I look at values that are separated by 2, and then I swap them. And then I look at ones that are next to each other and swap them. What's going to happen is that value at the very end that has to go all the way to the beginning, it's going to get there faster. Because what's going to happen is I'm going to look at, it's going to move 4 and then 4 and then 4, and it'll get there, a lot faster than if I just move it one spot, right? So essentially, comb sort is equivalent to multiple passes of bubble sort, but because it's moving data potentially faster into position, it looks like it's more efficient in certain cases. Yeah. All right. Other questions? Let's go back to the. Other questions about anything? Come on, you guys must be curious about something. I'll hang out for a few minutes to see if anybody works up a question or two. Talk sorting. We can talk, whatever people are curious about. Yeah, great question. Let's one start a project. Depends on what you're doing. It is. I mean, I'm not going to say that it's not intimidating, but I think the easiest way to push back on the intimidation factor is to do it, and to also just like don't take what you're doing too seriously at the beginning. Because when you do that, then it's like hard to start over. So for example, particularly when I'm using new tools and environments, I will start over all the time, right? Like I might spend a day where all I do is kind of like rerun the setup wizard and try to figure out like how to get things to work in the way that I want them or whatever, and just how to get things set up. For Android Studio, for example, like again, it really depends on what you want to do, right? One of the things I will say is that there are great tutorials and guides out there for pretty much any type of project that you might want to work on, whether it's a app on either platform, whether it's and part of the reason for this, right, is that like, as a developer, right, you're a creator, but you're also potentially a customer or a contributor or a client and so these frameworks, I mean, if you look at Android Studio, for example, there's fantastic documentation. And the reason is they want people to write Android apps, right? Like part of the strength of the Android platform is based on people adopting it and being willing to write apps for it. If Android had crappy apps, people wouldn't want to have an Android phone, right? I mean, to some degree, Google supports some of this themselves with their own developers, but they want there to be a marketplace out there where people can find solutions for things, right? And so they put a lot of work, and so does Apple with their iOS platform, and so does insert name of thing you want to do here, because people want developers to be able to use these tools and be able to build stuff. And so following the tutorials is a great way to do things. there are many, so frequently, what people will do is, and this is a great thing to do, particularly when you're getting started and you're learning, like, this is something I would do if I was trying to learn like a new language or a new tool, is go through a tutorial that you find online. A lot of times what those tutorials will do is they'll kind of show you how to build a particular type of app or a particular type of system. It probably isn't what you actually want to do, but it doesn't matter. It's just sort of like getting comfortable with some of the concepts and the idioms and some of that, right? So yeah, I mean, and like I said, I think the best way to get good at this is just to do it, right? And to do it in a way where you allow yourself to say, I'm just building something for fun. This is actually one of the things that's so great about, and I suspect less of this is happening now, which is too bad, but sort of hackathons that people would go to, right? I mean, one of the reasons why people like hackathons, I think, is because the community, because you get to meet other people, and maybe there's some prize or something. But I think the real thing that's healthy about hackathons is encouraging you to just like go for it, right? Like take something, try it, charge at it for a couple of days, but then also just be willing to be like, that was fun, like just drop it, right? It doesn't work out, took a bad turn, you made some bad decision along the way, it started to look ugly, didn't work very well, whatever. Just being able to be like, that's cool. You're gonna create lots of things, I mean, on some level, like working in software development is a lot like, like working is like creating art, right? Creating music, creating whatever. People start a lot of things. They have a lot of things that are kind of halfway done. Some things they never like. Some things get released because for reasons, right? Some things they end up releasing they don't like very much. Other things they've worked on for longer are sort of pet projects they do like. So, it just, and so it just lets this sort of, I think it helps to have a little bit of a distance and sort of from what you're doing, in the sense that you're not like thinking, this is the thing that I'm going to do that's going to define my entire career or whatever, this new project that I'm starting today. Because you don't know that, because a lot of the projects you start, like, you'll learn something from it and you'll have fun, but you'll forget that you ever tried to do that, right? It'll be like 6 months later and be like, oh yeah, I remember that time I tried to build a iOS app, that was weird. So, I think just, getting, making use of resources to the degree that, in a class like this one, we provide a forcing function to get you started in technology. But computer science is an area where it's so easy to, I started to use this phrase, I feel like it's a good fit for the situation. It's easy to live off the land. You go out online and there's so many good guides and tutorials and examples and stuff like that. And there's a huge community of people that are doing similar things and are really excited to talk to people and help you out and stuff like that. And so it doesn't take very much before you can get to the point where you can just sort of, you don't need school, and when you go off, and I don't know what your plans are for a future in technology or a career in this area, but you're going to have to, like, if I look at the stuff I'm doing now compared with the stuff I learned in college 20 years ago, I mean, it's like, I don't know, there's I'm sure there's some relation on some level. Like, I'm still writing loops, I wrote loops when I took CS1 21 years ago now. Is that right? Yeah, it's not that long. No, it was 2000. Who cares? Why am I even doing this? It was over 20 years ago, 1999, 21. Yeah, 21 falls ago. But like the technologies I'm using, the languages I'm using, the problems I'm thinking about, the ways I'm approaching things are just like sort of dramatically different. And that's going to continue to happen to you. Some people, I don't know. I mean, I think, to be honest, I think there's some people in technology that get a little turned off by that, because like things are changing all the time. But that is something that you just have to kind of learn to live with, because it's true, right? I mean, this is far from a settled field. I mean, if you think about even other engineering disciplines, I mean, there are new things that I don't want to slag on other engineering disciplines, but like some of those things people have been doing for a lot longer than we've been building software. And so stuff changes, right? I mean, people are building new things. The new things are pretty cool. So I don't know if I'm answering this question well or not, but I think it's just like trying stuff, right? Letting yourself fail, not getting too attached to anything. Also, seeing it as a journey and seeing it as preparation, right? There may come a day where you have a really exciting idea, right? Where you feel like you are in the right place at the right time. I mean, I've known some people in technology that have had this type of experience where, I knew a friend back from my days in Buffalo. He's a great guy, and he had worked at a bunch of tech companies in the area and was kind of, working as sort of an evangelist for technology and helping other people. And then suddenly, like, he just kind of ended up in the right place at the right time. Got involved with a startup that I think recently, was valued at over $1 billion, right? And it was just a combination of kind of like him being ready for that moment, right? Like having done a lot of things in technology, like none of them at that point had been like anywhere close to that successful, but he built up skills, he built up knowledge. And so when he saw it's like, here's this opportunity to do something really cool, he was ready, right? And he was ready because partly he did all these other things, side projects, little things, worked at companies, helping out with their tech stack that prepared him, right? And so it was not like he was like, oh, every time you start a project, this is going to be the thing that I'm going to make it big, right? With this, so it's like, no, probably not. Just the odds are against you, but you'll learn something from it, right? And you'll take that to the next thing you do, and then over time you start to build confidence and stuff like that. But yeah, I mean, there's figure out what you want to do, find something that you're at least excited enough about to stick with for a few weeks or a few months, find some tutorials, be patient. It takes time. You'll hit some weird roadblocks and you'll get stuck, and reach out to other people and find a community of people that's willing to help you. And that's how it gets done, right? There's also like no right or wrong way to do some of this stuff, right? It's just like, does it work? Like, do you like it? Is it solving the problem you want to solve? So yeah, I mean, it's something it takes practice like anything else, right? And to be honest, I think it's not just practice, but it's also just having the experience of doing it a few times and then starting to realize this is what it is, right? Like, it's like if you haven't done something before, doing it for the first time, you're just like, oh, that was weird. But then after you've done it a few more times, you start to realize what's normal about it. And particularly with starting a new project, I mean, it's normal to, I don't know, it's fine. I was thinking about this the other day, like after having done this a bunch of times and having a bunch of sort of little projects that I'm maintaining or working on, you get to the point where it's actually sort of exciting to start something new, because at least at the beginning, it's all fun. It's all possibility. It's all like, oh, I've got this great idea. And then, you get, as it becomes more real, it becomes more complicated, and you have to make trade-offs, and you make certain design decisions. You're not sure if they're the right ones or not, and then you have to live with the consequences. And so one of the things I was thinking about is just that, I think I have this tendency that I'm starting to learn to push back on, to want to start over, right? Just be like, burn it all down, start from scratch, and that's going to help. And because it's sort of fun to like have a white piece of paper in front of you and just be able to start over. What you don't realize until you've tried that a few times is that it doesn't really work, right? If you start over on the same problem, right? If you start over on a new problem, you solve a new problem, right? But when you have code that works and you're like, I'm going to destroy all that and rebuild it from the ground up, and it's going to be better and more beautiful, and it's going to have different problems, maybe, than the first attempt, but it's not necessarily going to be dramatically better. Sometimes, but it doesn't happen all that often. So anyway, I mean, I would say just, enjoy it, right? And the other thing, I mean, I tell people is, and I'm not trying to, be, I don't know. I mean, I don't know, but like, there's all these people that build Android apps, and like, you're probably smarter than many of them. Maybe not all of them, maybe not most of them, and I don't know, but like, you can do this, right? The people over there, like non-technical people, watch these tutorials, figure out how to get stuff to work, and put something together that solves a problem, right? So it's definitely doable. Feature ideas for the MP. Yeah, sure. Well, I mean, you could certainly, yeah, we'll probably talk about this more on the forum. But one obvious thing is to show course ratings for a course, not just the one that you. Actually, this was originally part of MP2, but I trimmed it because just doing the part that I think we're having you do is probably enough. So yeah, yeah, come to my office hours if you want to chat more. I'll probably do those again later this week. I'm not usually on the help site very much these days, but certainly one of our CAs will be able to help you with your code there. I jump on periodically, but I have some other things I'm working on. As far as MP features, so yeah, I mean, getting it to the point where it can display ratings from other clients, basically. So, and this is something that'll be a little hard to test because when you interact with it originally, you're only going to be looking at your ratings, and so the two things are going to look the same. So you might need to figure out how to do that. But yeah, I mean, being able to show ratings for a class would be obviously that's something that's sort of straightforward. Scheduling features would be straightforward, like being able to help people build a schedule of courses that don't overlap with each other. That would be kind of nice. There is, so if you look at that JSON that we're giving you about the course, there's quite a bit of information in there that you guys are not parsing yet. I mean, you guys are pulling out the description, but there's all kinds of stuff in there, right? There's information about meeting times, about instructors, about prerequisites. Now, some of this stuff is human entered text, and so it may not be super easy to pull out, but it might be fun to try, right? Like even the credit hours, right? I mean, that's something where you're just like, why isn't this just a number? But then like there are these weird courses where it's like sometimes it's a certain number of credit, or it's like it can be a different number depending on the agreement between the instructor and the student, whatever. So like this stuff gets super weird. So those are some ideas. Adding like a real login would be something that you would actually have to do to get this to work for real. So integrating this with probably I'd suggest Google Sign-In. Illinois login supports Google Sign-In. So basically, we have an integration with Google Login. This is what we use for the website, right? We have an integration with Google Login such that people can use Google Login, configure it so that it redirects you through the Illinois login flow. That's something that you can do, and I think that will also work on the app. I haven't tried these things, by the way, right? So I have no idea if they'll work or not. At some point, what we might do, I don't know, it depends on how bored I get over break, is deploy the backend in on a server somewhere. And then at that point, what you could do is you could essentially transition from using the built-in backend that you guys have been working with so far to using our remote backend. One thing I'm actually thinking about doing, I've been teaching this Kotlin class, or I taught it last spring, and I think I'm going to teach it again this spring. So what we might do in that class, if you're interested, is we might actually, we'll learn some Kotlin basics. But what we might do for a project is we might take the MP from fall and rewrite it in Kotlin, including the backend. So kind of setting up a little bit more of a complete development environment with the app that's written in Kotlin, which I think would be a lot of fun. I've never done that, so I need to learn at some point. And then the backend in Kotlin, which I have done. And so having those two kind of fit in with each other, that would be fun. So that might be something that we just do as a side project in that class, or as the class project, right? So yeah, these are some ideas, and I think I could also probably set up. I'm trying to think about how Google Login works. I think I could set up the backend server so that it integrates with, and I can just tell you guys what the Google Login client ID is, and you guys could use that to connect to the backend server. So the way this works, again, the way the client ID works right now is pretty sketchy. The way you would do this for real is when you would submit a rating, you would send along a token. That token would be something that the backend would be able to validate that is associated with an email address, and then it would store the rating for that user based on their email address rather than based on this client ID, right? The thing you worry about is just, vote stuffing, right? I don't want to set up a system where I can easily write a script that just jams in, hundreds of bogus ratings for a class, right? I mean, I guess somebody already built that system. It's called Rate My Professor, but we don't want to rebuild that. So, associate for 125. So the associate. So there may be some confusion about terminology here. So the associates are typically hired from our current course staff. So we typically don't hire people directly into an associate role. Now, there are exceptions, right? We have maybe one associate this semester, I think, maybe one, who was a student in spring and was just obviously extremely, knowledgeable. But we usually don't hire students straight into paid roles. What we do allow you to do, and this is open to anyone who's in 125, is serve as a course assistant. And we'll talk more about that after break. But there's really no application process for it. Like, there's a button you click on the website and it just works. Though course assistants are doing this for course credit, so that's I think 1 credit hour of ungraded pass-fail course credit. And we ask you to do a few hours a week. Typically, what course assistants have been involved in doing is office hours, and we'll definitely have some of that to do next semester. But one of the things I'd like to try to do is also involve the staff more in creating content for the site. So adding explanations for the various, basically adding anywhere you see like a code walkthrough or a video walkthrough right now, those are spaces in each lesson that are actually open to staff contributions. And so I'm hoping to get more people involved in generating content for the site. So students have, different voices that they can hear from. I think that, as someone who has to generate all of the content, right? I mean, I certainly am rushing things sometimes, right? Where I don't necessarily have time to sit down and think about, what's the perfect way to explain this concept or come up with a prop or whatever. And I think that, if it was like you have to do one explanation per week as opposed to 20, which is my job, although I'm getting close to the end, I think people might come up with some better ideas. And I think just the staff, the diversity of thought and explanation within the staff is something that we want to start to harness. So that may be part of the role next semester. Yeah. Oh, yeah. So that's the plan for staff. And again, we'll talk more about this. It's not. The application process for course assistants is extremely simple. The other thing I'm waiting on a little bit, particularly for paid staff, is I don't know what the enrollment will be like in the spring. So we'll see. I think registration starts soon, and I suspect by the end of the semester we'll have some idea of what the numbers look like. The spring enrollment is typically smaller. Many times it's been quite a bit smaller. And I think this semester it might even be smaller than usual because, I have to bore you with these details, but what we've typically had a cap on enrollment in CS 125 in the fall of about 800. And I think what that has done is it's had forced some students, particularly freshmen, who might have wanted to take the class to take it in the spring because they couldn't register in the fall. Well, this fall, we started the semester with like 1,200 students, so we, took the cap up. I don't think we ever got to 1,200. Maybe it was like 1,100. We took the cap off, and so I think everybody wanted to take the course got in, and so I don't know what we'll see in the spring. If it'll be smaller, I anticipate it will be smaller. It may be dramatically smaller, which is fine. I don't. The numbers are not. Particularly important to me, but that does affect how many paid staff we can afford. So, great questions. Any other last thoughts before I head to lunch? right. Well, thanks everyone for showing up. So tomorrow we'll do merge sort. Next step, and I think you guys have provided some great feedback on the lesson, and I'll probably bring in some of the data dependency stuff into tomorrow's lesson as well. So I will see you then.